where are we going to start? We will connect the longest connections, and then we will focus and connect all these small and short connections. Click on the layer 1, that's the layer where we would like to draw the tracks, and click on this button here. This is what is going to draw the tracks. Click in the middle of a path. You see the special cursor, and just drag the track. Here, when you would like to finish it, double click with the left button on your mouse and then right click once. 1, 2, 3. Okay? Connect. 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 If you would like to change the track width, press Tab. At this moment, we are using 0.3, that's what we set in the rules. If you would like to change it, you can put here like 0.5, for example. Yeah, it's now 0.5. I will put there back 0.3. Okay, and I will connect also this. Click, click, double click, right click, click, double click, right click. At this moment you can just route the tracks as you like. A little bit later we will make them look nicer, so it's not really important at this stage of the layout how the tracks look. Just try to connect them. Continue down here and connect the microcontroller with this header. Ideally, on a 2-layer PCB, you would like to route most of the signals on 1 layer only. In our case, we will try to route most of the signals on the top layer, because the other layer, the bottom layer, we will use for ground plane and for power planes. 2-layer PCB is very special because ideally when you are doing PCB layout, you would like to have at least 1 layer which is full ground. So ideally you would like to have 1 layer where all this is just a ground plane. Because it's not possible on 2-layer PCB, that's why we try to route all the tracks on the top layer and make as big as possible ground plane on the bottom layer of the PCB. Now it's getting a little bit more complicated because all the tracks here, they are crossing each other. Let's have a look how they are connected. Press Ctrl, hold it down and click on this path. Okay, this is connected here. This one, this one, this one, this one. I will route it this way. Connect this. Connect this. Now there is a special mode. When you press Shift R, watch down here, you will see there different kind of routing modes. I click again on the track. Now we are using walk around obstacles. Can you see it? It means based on the rules, the tracks will walk around the vias, around the paths, around the tracks. So the space, the gap, is based on the rules. It is 0.2 millimeter. See? When you press Shift R, you change the mode which you are using to route it. Now it says push obstacles. Now when I route, I can push what was already routed there. See? It's much easier now connect the tracks together. There are some other modes. Press Shift R again, hack and push obstacles. I don't use this. Shift R, stop at first obstacle, it just stops. Press Shift R, auto route current layer, I don't use this. Press Shift R, auto route, ignore obstacles. You can go through what you already routed. Can you see it? I don't use all of these. I will show you how you can switch them off in the Altium default settings. I will just finish routing this signal. Shift R, push obstacles, and I will route it this way. Click on DXP, Preferences, PCB Editor, Interactive Routing, and only leave check the ignore obstacles, push obstacles, and walk around obstacles. These others, I never use them. Also, what I don't use is allow via pushing. Uncheck this. If you like, you can try to play with these settings, but this is what I use for really difficult and complicated PCBs, and it works really fine. Okay. To route these two signals here, we will need to use also the bottom layer. I'm going to show you how you can route also on the bottom layer. First, I will reroute this a little bit, because on the bottom layer we would like to route only as short tracks or just minimum tracks as possible, because we would like to have there the big ground plane and the big power planes. So reroute it this way, go up and route this signal here. Click, press plus and minus, you can change the layers, and it will also automatically place via on the PCB. Via will connect the top with the bottom layer. So press plus, click again, and see, you are routing on the bottom layer. Click again, minus, click again, and connect the pin. Very similar for the other pin. Zoom in, click, go down here, click, plus, click, minus, click, and connect it. We can reroute this here a little bit, so it's not so messy. And we can continue with the other tracks. Go here, press Ctrl, hold it down, highlight it. We are going to connect it with these two pins. Zoom in, plus, minus, and connect these two. The next really long tracks are these here. Because when we will be routing it, it's going to cross all these tracks which are here. The best way to route them will be probably use the bottom layer. Press Ctrl, hold it down, highlight the net, press Shift S, go to single layer mode. We are on the top layer now. Click down here on the layer 2, so we can see what is routed on the bottom layer, only these few tracks. Zoom in, click, and route it. Okay, click, highlight this one, and I will do it this way. I will reroute this, go around this pin, I'll make it nicer, and connect this one. Perfect. Press square brackets. I will change the intensity of the highlight a little bit so you can see it better on the video, maybe like this. And here are some long connections. Let's connect them. This one. Again, it's crossing all these tracks, so we will need to route it on the bottom layer, or part of this track we need to route on the bottom layer. Ideally, we would like to route it close to these tracks which are here, because we would like to still have the big ground plane somewhere here. Go on the top, reroute this signal a little bit. Click here, plus go on the bottom layer and go somewhere here. We need to go on the top and draw the connection here. Best way to do it is to move these resistors a little bit up, maybe like this, and move these tracks which are here. Somewhere here. Okay, go on the bottom, minus, and draw the track here. Same for this other signal, this one. Click, go here, plus, continue, put the via here, and connect it. Highlight this, click, and route it. Plus, go somewhere here, minus, connect this resistor, and connect this pin. Zoom out, and what is the other really long connection? This one here. Same as in these cases here, we need to route it through all these tracks on the top layer, so we will use the bottom layer, and the best way to route it will be go close to these other tracks here. See, during the layout you always need to think ahead. We could route it somehow this way or this way and connect it this way, but there would not be space for a really nice ground plane down here. So I'm thinking how to keep these tracks on the bottom layer together. Click here, connect this, and route it this way. This is a little bit wider track. Can you see it? It's because it's PowerNet. It starts with plus. Here we can connect it a little bit differently. I will go around this pin and this way. Route somewhere here. Minus and connect them together. Nice. Can you see? No long connections here. Route this one. This is reset. If you hold a cursor on a net or on a path down here, can you see it? You can read the net name 328p reset n. If you hold it here, +5/3.3 volts. Click. How we are going to route it? Tell me, what do you think? Same as before, we would like to ideally route it together with these other tracks which are on the bottom. We don't want to split the ground plane which will be here. So go here, click and route it. And I can see the track is wider. Press tab. We would like to route it by 0.3 millimeter. Sometimes this change here, can you see it? Here should be rule preferred or rule minimum, what you would like to use. 0.3, okay, now it's fine, 0.3 millimeter. Draw it like this. We can go up. I will move this a little bit down. Place a via and route this way and connect it here. Zoom out, press Ctrl and click somewhere to unhighlight the PCB. Go on the top layer and we are going to connect the rest of the signals, okay? The ground and the power nets we will connect on the end. We can start, for example, from this corner. Zoom in, click and connect it. Click and connect it. This is ground, so do not connect this yet. Click, connect, this is power. Click, connect, click, connect all these together. This one and also this one. I will repair this. Okay. Zoom out and connect crystal here. Click, connect, 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 click, connect, connect, connect. Sometimes people don't like these sharp edges here. Can you see it here? From my experience, it's not a problem. So if you have it in the PCB, they can manufacture it. If you don't like it, you can just move it and make the connection so you don't have the sharp edges there. Go up here and we are going to connect these pins. What is here? It's the SPI interface and the reset. It's going to be easy connection. Can you see how it is connected? This reset maybe I would route on the bottom layer because here is clock. We don't want to route reset very close to the clock. Go on the bottom layer and connect it. Go back on the top, click here, connect the MOSI. Do not route close to the mounting hole. Route around it, okay? Somewhere here. And connect it. This one. This way. Press plus, go on the bottom and connect it here. Go back on the top layer and connect also this clock. I will make this area a little bit nicer so it doesn't look so horrible. Click, route it. Delete this. And draw the connection again. I will draw it from here. And connect this clock directly to the pin. Zoom out the PCB and move to this area. This is power. And we can start connecting here. Click and connect. This one I will connect this way. This one is connected here. Here. connect the area here. Also this. Connect the crystal. And continue down here. Now the USB signals, this one, this one, this one, and this one. USB signals are very special signals because these are differential pair signals. It means that you need to route the signals close to each other. They need to be routed together, plus and minus signal, negative and positive signal. It also means that differential pair signals should follow some rules. For example, they should be routed by specific recommended differential pair impedance. You don't need to know what does it mean. The thing is, we cannot meet this rule on two-layer PCB, so we cannot follow it. What we will try to do, and if you are routing two-layer PCB and using signals like USB, what we should do, we should try to keep the USB connection as short as possible. Okay, these tracks here, we need to try them route as short possible, and we will route them together. We will use standard track width and standard gap. It's not the proper way how to route it, but on this two-layer PCB we do not really have many other options. Zoom in and connect the USB pads. Plus, go on the top, Control C, Control V. Go on the top, plus, go on the bottom, plus. And USB is routed. As I said, this is not the best way how to route the USB, but for this two-layer PCB, this is just fine. Important is keep it as short as possible. Zoom out, press Ctrl, hold it down, and highlight the trunk. What left are mostly the powers and the ground, and couple of signals. We are going to connect the powers. We will use tracks at this moment, but later when we will be improving the layout, we will change the tracks for polygons, for copper planes. Zoom in. We are going to connect this +5 USB power. Click and connect. First, what is very important when you are connecting powers is to know how high current is going to flow through the tracks and through the vias. Do you know what is the maximum supported current for this USB micro connector? What is the maximum current allowed flowing through one pin of this connector? You can go to datasheet and you will see they say it's 1.8 amp. So if you would like to support this 1.8 amp, you need to be sure the track connection is wide enough so it can carry 1.8 amp, and you need to be also sure you have enough vias placed in this connection, because one via only can carry some maximum current. For example, for this kind of vias which we have in our design, the maximum current is 1.8 amp. Just to be sure, we will place there two vias. Ctrl C, Ctrl V. Okay, go on the bottom layer. Do not connect all of them like this, because one will disappear. Just start routing from this one. Go down here and place another two vias here. Click one and the second one. Go on the top and route this. Highlight the +5 volts, this one, and have a look how we could connect it. On the bottom, we will connect it this way. I'm going to do it. Okay, on the top we can connect it this way. Don't forget, later we will be drawing the polygons, so these tracks what we are drawing are just temporary tracks. Really do not worry about how they look. And also here. The next one we can connect 3.3 volts, this one here. Go on the bottom again and connect it here. on the top. And also here. Zoom out. Select this local +5/3.3 16U2 power and connect the paths. Here is one more. Plus. Plus. Find and highlight another local power, for example this one here. It's +5/3.3 328p VCC. Move this a little bit. Click here, connect it, go down here, plus, and draw it here, minus, connect with these components. Connect also this small local power here. Zoom in, click, connect it, connect this one here. Be sure the track width is 0.3. Press tab, 0.3. Okay. Connect this user button. Connect this output. Plus. Zoom out. Connect also this here. Click. Connect. And also this here. Plus. Minus. Plus. Minus. It looks like only what left is this small local power here, the ground, and +5/3.3 volt. Connect this. Zoom out. Highlight the +5/3.3 volt, this one, and connect it. I will start here. Go on the bottom layer, plus, go on the top layer and place the vias here, plus. I will copy the via, select it, Ctrl C, Ctrl V, connect it, Ctrl V, connect, 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 Ctrl V, connect. Go up here, connect these 3 pins, plus, go up here, plus, also here, plus, connect it, top layer, connect these 2 together, go somewhere here, plus, plus, connect this, plus, I will reroute this way, connect, go on the top, connect these 2 together, plus, and connect it here. Connect, go on the bottom layer, connect, and connect. We have fully routed the plus 5/3.3 volt power, but because it's quite big, we can set color also for this power net. Click on a path, for example this one, click here, right click, change color net, and we can use, for example, this one. OK, OK. Only what left is the ground. Highlight it and connect all the ground pins. We are connecting them together to see where and how we will draw the planes a little bit later. And also we are connecting them together because we would like to be sure when we run the VRC check that everything is connected. Plus, go on the top and continue here. Plus, Same here. Plus. Connect this. Plus. Plus. Okay, here are also some. I know it's taking quite long, but it's because, you know, there are a lot of ground connections. Oops. Few more. Almost done. Okay, okay. Also here. And here. Here. and here. Is it all? Did we forget something? Here. Now just go on the bottom layer and connect the rest of the signals together. Click on the layer tool and connect it here. Here. And also here. Plus or minus, go on the top layer. Plus and connect it. Here is one more connection, I can see it. And also here is something. And here. Yeah, it looks like we have connected everything. Click on Tools, Design Rule Check, select Electrical and check this. We would like to see also the unrouted nets. Run Design Rule Check and have a look how many errors we still have there. 5. One is net antenna. I will show you what this means. 3 are the errors what we will fix by the end of the design. And 1 unrouted net. This is very important. We need to find where is this unrouted net. Go back to PCB. Here it is. Double click. Jump, highlight. It's here. Click and place a via here. Go to Tools, run the Design Rule Check again. So we can see if we fix that error. It's gone. Unrouted net constraints, 0. Everything is electrically connected. There is still the antenna. Double click. Jump, highlight. Okay, I know why this is here. Can you see what the problem is? It goes here and it continues from this via. So this piece of the track is basically not used. That's what Altium calls net antenna. But we still would like to have 2 vias here. So we need to, or we would like to connect it on this bottom side here. But when we connect it, do you remember why we connected it from here? This via would disappear because of the automatic loop removal. What I will do, I will lock down these vias. When you lock them down, Altium will not remove them. Double click, lock it, OK. Double click, lock it, OK. And now we can connect them like this. Perfect. We can do the same also here. Double click, lock it down, double click, lock it down. Click on Tools, Design Rule Check, run Design Rule Check again and have a look if we fixed also the antenna error. Rule violations 3 and net antenna 0, unrouted net 0. Only what left is the silk to solder mask error. Perfect. Even we electrically connected all the pins, it doesn't mean the PCB is done. We are going to do a couple of more things. We are going to improve the tracks, especially the power tracks. They need to be white. We need to create the power planes, and also we will make it nicer. Yeah, you can see by yourself it doesn't look really nice at this moment, and when someone takes your PCB, you would like to them say like, wow, what nice PCB. Also, there is something really special about this PCB. It's a 2-layer PCB and it's very simple PCB. The process how we did the layout of this PCB may be a little bit different, or I'm sure it is a little bit different than when you are doing layout of very complicated high density PCBs with a lot of components and a lot of tracks. For example, the biggest difference in how we routed this is if you have complicated PCB, you need to start from the most important interfaces, for example, memories. You need to start from difficult areas, like under BGA. And for example, one of the biggest differences is in the complicated PCB, you really would like to place all the vias before you are doing the layout, before you draw the tracks. So for example, the ground vias, the power vias, you need to place them there. What do you think? Why? Because if you don't have space, you really don't want to keep rerouting the layout. When you place the vias first, then you can route around them. If you route the tracks first and you place the vias, you need to reroute what you already done. Here, this was very simple. There is a lot of free space, so we could very easily connect the power by the end of the layout. But as I said, process of designing this two-layer simple PCB is a little bit different than how you design really complicated PCBs. Go back to our PCB and we are going to draw the polygons. Click on the layer tool, Shift S, go to single layer mode, press right click, set the grid to be 0.1 millimeter. Highlight the plus 5 volts. This is what we are going to do as the first power net. Select one of the tracks, press tab, select all the tracks on the bottom layer and delete them. Click on Place, Polygon Pour. Solid, check this, leave the number as it is, leave the number, check this. Select plus 5, select pour over all same net objects, check remove dead copper. Okay. Go down here. We are not going to draw from the edge of the PCB. I will move it a little bit. 1, 2, 3, 1, 2, 3. Click. Go up. Click. 1, 2, 3. Leave a little bit space. Yeah, mostly 1, 2, 3. 0.3 millimeter around the object. And connect this pin here. Again, do not go down. 1, 2, 3. Do it like this. And double click. Right click on your mouse. And it is done. We have created the polygon, but we don't want to have this kind of connection. We would like to connect it directly.